So this is the video for section 2.5 called piecewise functions. Now, this is going to be something that you probably have not seen before, but it's no different than what we've been doing throughout this unit where we're graphing lines. All right, so a function that is made up of several pieces from different equations is called a piecewise function. Okay, piecewise function. So if you look down here at example 1, it says, when you first look over here at the equation, it's kind of strange. It says f of x equals, and then you have this kind of bracket thing, this brace, and then you'll see two different equations. Okay, here's the first equation, x plus 1. Here's the second equation, negative 3x plus 1. So there's two different pieces to this equation. Now, sometimes you're going to use the x plus 1 line, and sometimes we're going to use the 3x, the negative 3x plus 1 line. How do I know when to use what line? Well, that's what this part tells me. So I'm going to use the x plus 1 line whenever x is less than 0. So look down here at the x-axis, right? Here's the x-axis. And if you look at the numbers on the x-axis, x is less than 0 everywhere over here on the left of the y-axis, right? So that means on this side of the graph, we're going to use the equation y equals x plus 1. And I say y equals because doesn't f of x just mean y? So this could have just as easily have said y equals these two different things. But then notice it says we're going to use the negative 3x plus 1 whenever x is greater than 0. Well, isn't x greater than 0 over here on the other side? So everything on the right side is when we're going to use the equation y equals negative 3x plus 1. Okay, so there's two different equations, and we're going to use a piece of each of them. All right, so here's how it works. Let's start with the y equals x plus 1. So forget about the fact that there's two equations, forget about the fact that this is piecewise, and just graph that first line, y equals x plus 1. All right, if I'm going to graph y equals x plus 1, it's just a line, right? My y-intercept is 1. There's my y-intercept. And my slope is 1, right? Because the 1 on the x. So up 1 over 1. And I could draw this as many times as I want in both directions. But if I were just graphing this line, it would be this entire thing, right? So that whole thing is the line y equals x plus 1. Well, I don't want the entire line, right? Remember we said we only want the part that is over here on the left of the y-axis. So that means the only part of this line that I want to keep is going to be from right here on the y-axis, and then I'm going to keep it all the way over this direction, right? So I'm going to erase the other side. I don't want the other side. I only want the part that is to the left of the y-axis. Okay, so this is the y equals x plus 1. There's only one thing you have to be careful of. Notice how it says y, or when x is less than 0, not when x equals 0. So since it doesn't have the little equal sign like the second one does, that means I do not want to include that endpoint. So it's kind of like saying, okay, this endpoint is like a hole. I don't want to include that endpoint because there's no equal to on that graph. Okay, so now I'm going to graph the other side. I'm going to graph the y equals negative 3x plus 1 side. So forget about that blue line that's there. Ignore that that's there, and let's just graph negative 3x plus 1. So I have a y-intercept of 1 right here. I have a slope of negative 3, so down 3 over 1, down 3 over 1, as many times as you want. And if I wanted to draw the entire line, it would be this whole thing, right? It'd be this whole thing. But remember how we said we don't want the entire line. We only want the part that is over on the right. So I only want the part of the line that is over here on the right side. So I'm going to erase the left side of that line. And on this one, because there is the equal to right there, see how it says greater than or equal to, that means I do want that solid dot, even though that in this case the solid dot filled into the open circle that was on the blue line. So that right there, that kind of, you know, V, little bit of a V shape, is the piecewise function. So we used one piece from the first equation and one piece from the second equation. And in this case, the two lines kind of connected up right in here, you know, when x equals 0. That might happen and that might not happen. Okay, so let's look at the next one. So this time I have the two pieces, negative 3x plus 1. So one of my equations is y equals negative 3x plus 1. And the other equation is y equals negative x plus 3. But this time, it's not just the left and the right of the y-axis, but notice it's when x is less than negative 1 versus when x is greater than negative 1. Now, I'm going to kind of put in this kind of imaginary line, so I can draw it kind of real light. Right in here is when x is negative 1. I'm just kind of drawing this to help me see on the one side of that line, on the left side, when x is less than that, we're going to use this first equation. Okay, so let's do that one. Y-intercept of 1, slope of negative 3, so down 3 over 1, and you could mark that off in either direction, right? You could mark that off in either direction. And if I drew the entire line, it would be this whole thing. But I only want the part when x is less than negative 1. So I only want the part from this point right here over to the left. Over here is when x is less than. So I'm going to erase the other part. So I don't want this part that's to the right of negative 1. I only want that part to the left. And notice because it said I wanted when y is less than or equal to, that's how I know I want this to be a solid dot right there on the end point. Okay, so now I'm going to look at the other equation. The other equation is negative x plus 3. So y-intercept of 3. And if my slope is negative 1, that's going to be down 1 over 1, down 1 over 1. Again, as many times as you want to mark it off. If I were going to draw the entire line, it would come through something like this, right? But remember, we don't want the whole thing. We only want the part from negative 1, which we know is right here. If I can get that drawn in there, which is right here, that goes to the right side, right? This side over here. This is the part that I want to keep, so I'm going to erase the other part. I'm only going to keep this side. And so on this one, even though my second equation kind of had this open circle right there, but wasn't there already a solid green dot underneath it? So it's like when they come together, they kind of come together at that point, what is that, negative 1, 4. So in this case, again, the two lines met up right there at negative 1. Now, I'm going to take off this little kind of imaginary line just because I don't want you to think that's really part of the graph. I just did that to kind of help me, you know, which part of each line I wanted. Okay, so let's go to this one. I know it looks intimidating when you see all those fractions, but you got to look at them separately. So let's just start with this equation and ignore all else. Okay, so y-intercept of 2, slope of negative 2/3 down to, oops, that wasn't negative 2/3. So down to over 3, right? Down to over 3. Or I'll go this way. I like to go both directions just to kind of give me a little bit going. So if I were going to draw the entire line, it would be this whole thing. But this time, where do I want to cut it off? Well, notice it says I want when x is less than 3. Well, here is where x equals 3. And if I want the less than, that means I want the line that's over here on this side, right? I want the line that goes from 3 right here over to the left. I want this side. Right, so I'm going to erase everything else except for that side. And then I need to decide, all right, on this one, do I want that to be an open or closed circle? Notice there was no equal to, so I need this to be kind of an open circle right here. right? There's kind of an open circle, okay? And now for my second equation, I'm going to look at negative 2x plus 4. So ignore what's there. Y-intercept of 4, negative 2 over 1, negative 2, so on. So if I were to draw this line, negative 2, it would do something like this. All right. So on this one, I want the part when x is greater than or equal to 3. Well, here's where x is 3, and that hits my line right here. Since I want greater than, that means I want the part of the line that is on the right side. So I'm going to delete the part that was to the left of 3. Okay, so I've got this line goes out here to the right, and then because of the equal to right there, I do want that to be a solid dot. So notice on this one, the two pieces did not connect. That's okay. They don't have to. You just have to kind of draw your graph as accurately as you can and see if they connect or not. So because of that, I want to add something to our box that we were writing up here. The second part here, it says a piecewise function may or may not be continuous. It may or may not be continuous, meaning it may not connect. In other words, it may have breaks or holes in the graph, right? The two pieces might not come together. There might be a break in the graph. Okay, so let's look here at number 4. Now number 4 does not ask me to graph. It simply says, here is my f of x, and then it asks me two questions. What is f of negative 3 and what is f of 4? Well, remember, function notation means you just plug that number in for x, right? But remember, f of x is defined two different ways. Sometimes f of x is defined as 10, and sometimes f of x is defined as negative 1. So how do I know which one I should plug this into? Well, you look over here. I'm going to use the first equation when x is less than 4, and I'm going to use the second equation when x is more than 4. Well, if x is negative 3, that's definitely less than 4, isn't it? So that means I'm going to use the first equation. So if I plug a negative 3 everywhere I see an x, you'd say, oh, well, there aren't any x's. You're right. So all I have is 10. On this one down here, f of 4, so I want to plug in a 4 everywhere I see an x. So which equation do I use? Well, if x is equal to 4, don't I use this one? All right, so if I plug in a 4 everywhere I see an x in this equation, well, there aren't any x's. So all I have is negative 1. Okay, now look at number 5. Now I know it has 3 pieces. That's okay. And I know that middle piece isn't even a line. That's okay. They're not asking me to graph it. So let's see if we can evaluate. Well, if I want f of negative, oh, look, this should say g. Sorry about that, right? Because this is defined as g. Okay, so if I want to find g of negative 3, I need to figure out, this time there's 3 pieces. Which one should I plug in if x is negative 3? Well, isn't this equation going to be used anytime x is less than 0? And negative 3 is definitely less than 0. So that means I'm going to plug negative 3 in for x into that first equation. So I would have 3 times negative 3 minus 1, which comes out to be, let's see, negative 9 minus 1 is negative 10. Okay, you do notice I'm not plugging negative 3 into all of them. I'm only plugging it into the one that it's defined on. Okay, what if I want to find g of 4? Well, if I want x to be 4, which piece would I use? Well, the first one, x is less than 0. The second piece, that's when x is between 0 and 4, but notice it doesn't say equal to 4. The third piece, though, it says when x is more than or equal to 4. So I'm going to plug it into this last equation. So if I put a 4 in place of x right there, I'm going to have 1 minus 4, which is negative 3. Okay? So that's just if I have to do function notation on these piecewise. You don't plug it into all of the pieces. You only plug it into the one piece where it's defined for that number. All right, so let's do a little bit more graphing. It's funny because I find that sometimes, when you have a problem that's almost so simple, it makes it seem harder. Notice on this one, my two equations are simply, this one is y equals 4, but this one is y equals -2. Well, aren't those both horizontal lines? Yeah, they are. So if I were going to draw the y equals 4 horizontal line up here, but I only want the part of it when x is less than or equal to -1. Well, here's where x is equal to -1. And if I want the part that's less than, that means I want the part that's over here on the left, right? So I'm going to erase the other side. I only want this side. I kind of got it off of my line. Sorry about that. And I'll put my arrows on there. Ooh, that's kind of a giant arrow. And then notice I have the solid dot because of the equal to, right? All right, let's go to the other side. Y equals -2. Well, if I were going to draw y, hush. Milo, shut it.